4.1, here we go. Operations with polynomials. Everybody ready?
Yes.
Great. Next slide.
Exponent.
Okay. First off, when you do that, what do? Don't actually do it, but FOIL, right? Okay. And you do x times x, which is x squared. Why is it x squared?
Because it's x times x.
Because it's x times x. Okay, so what if I made these squares here? Why? Because you're adding up the exponents. Very good. Okay, now, let's get rid of all that. I said cut. Okay. Now, what if we had something like this?
X is x.
Why? Good. Okay. Because what you can do, and this is a long way now, you can do x times x times x divided by x, and then two of those x's cancel to leave you with x squared, right? When you put them back together after that. Okay. Here's one that always everybody gets messy with. That's a terrible 3. Let's try that again. What's that? X to the 6. Okay. Now I know how, but here's why. When you do, like, let's say 2 cubed, you're doing 2 times 2 times 2, right? Okay. Same thing here. You're doing x squared times x squared times x squared. You're turning it into a problem like the one that I unfortunately erased, right? Where you had x times x. Here you have the same thing. You have x squared times x squared times x squared, which means you add those 2's up, which gives you x to the 6. Okay, good. Okay, that's that one. Same logic now. Stick with this one. If you have xy quantity squared, you do xy times xy, which means the exponent of 2 goes to each variable. Good. So it becomes xy times xy, which goes x squared y squared. Okay. Let's see. What am I missing? I know one of them that I'm missing. Let's just get this one out of the way. X to the 0. What's that?
0.
Nope.
Is it
1. Anything to the 0 power is 1. Okay. Anything to the 0 power is 1. All right. Now, the one that people most often get messy with or get messed up with. Let's say it's 1 over x to the negative 3rd. What's that change to?
Would it still be x to the negative 3rd?
Nope.
Can you not have negative denominator?
You can't have negative exponents, period.
So times by negative 1?
Nope.
Can't answer it.
False.
Is it 1?
Wait, reciprocal?
Nope.
Something with an I.
Can't answer it.
Ossoff. Over here, what do we do? Subtracted. Okay, now, over here, there was x cubed and x, so we had them both, right? Over here, there's not an x up there, so let's make one, huh? X to the 0 over x to the negative 3rd. What's 0 minus a negative 3?
Oh, x to the 3rd.
Plus 3. That's how that works, okay? So skipping that middle step, what do?
You add instead of subtract.
No, not yet. No, not from. Skip this step. What did I do from here to here? Literally.
You change from negative to positive.
You change it from negative to positive, and you move it from the bottom to the top, denominator to numerator. See that? Okay? You can do that with any of them. Okay? If it's negative down below, it'll be positive at the top. Okay? Now, for a very similar reason, since that one works this way, or since that one works this way, rather, let's say it was x to the negative second. Turn that one positive. What would it be?
X to the second.
Wait, x over 0.
1 over x to the
Oh
second.
yeah.
Because if it's negative in the numerator,
Oh, because x to the third equals 1 over x to the negative.
there you go. See? Right here, these two are the ones that cause everybody problems. Okay? Is when we get to these negative exponents. And I don't know if anybody's used negative exponents in the past before. We're going to start today. Okay? Stone.
How does? Can you explain that?
This one here. Since you have it comes from your subtraction rule from over here, right? So when you're over here, you write these 3 x's out. You have this one down below. They cancel. You get x squared. Okay. The shortcut to it, like we said when we did this one, you do this exponent minus this exponent to give you this exponent. Okay. When you have this over here, you don't have an x up top, but you approach it the same way. So when you don't have something, it's 0. So you have an x to the 0 over an x to the negative third. You do 0 minus a negative 3. Clean your signs up in the middle. 0 plus 3, 3.
Oh, 0 minus negative 3.
Okay. Now, the middle ground to this one is much nastier. Okay. Which is why you can just derive the rule that all you do is just move it to the other side of the fraction and change the sign on the exponent. Okay? I think the only actual rule I missed was one like this. X over y. That was a terrible y, but let's roll with it. Cubed. It's just like this one here, how they both get squared. These, they both get cubed. Okay, so x cubed over y cubed. Okay. Any questions on that? Everybody good? Great, moving on. Stone, you good? Okay. Basically, that's what I just did in all these rules. You don't have, here's the thing. These rules tell you how you work the problems that we're going to work. Okay? Do you need to know these letter relationships and that this one is called quotient of powers? No, you do not. Okay? You need to make sure that you know how each one works. And that's exactly what we just got done talking about, okay? Your product of powers rule. Multiplying 2 bases, add up the exponents. So x squared times x cubed, for example, gives you x to the 5th. 2 plus 3. Your quotient, you subtract them. Okay? So when you're multiplying, you add the exponents. When you're dividing, you subtract the exponents. We just went through the negative exponent deal, okay, in pretty good detail. Power of a power is where you have that third one that we did, right? X to the second to the third. That's where you multiply them. These two we just did late towards the end. If you have a product that's 2 1 power, you put it to both. Same with the quotient. And then your 0 power, anything to the 0 power is 1. Okay, so do you have to know those names to match up to those rules? No, you do not. But those are the 7, I think it's 7. 1, 2, 3, 4. Yeah. Those are the 7 rules that are going to help you get through all these different types of problems that we're going to be doing these next 2 days. Okay? Does that make sense? Everybody good? Okay. Make sure you did you guys get the definition for simplifying now?
No.
Make sure you get that. I did skip over that, okay? Simplify. It's actually got a definition to it. It means rewrite the expression without parentheses or negative exponents. So whenever we are working these problems, that's your main 2 goals. Okay? Because these directions are going to be very basic. They're going to say simplify. That's it. Okay, so you got to know where to take it from there. That's what you're mainly looking for, and if you peek ahead, the next slide, you have 4 more bullet points to follow. Okay? And those two are kind of included on those bullets for the next. Okay, so simplify technically means rewrite the expression without parentheses or negative exponents. Negative exponents, bad. Positive exponents, good.
Good.
Okay? Everybody good up there? And next slide. So there's your 4 main points you want to make sure whenever you're working these problems out that you hit. Okay? Bless you.
No.
No,
So just unnecessary.
I was cleaning the what?
Damn.
You don't have to do it out loud.
Alright. A monomial expression is in simplified form when? Number 1, no powers of powers.
What does that mean?
That means you don't have x squareds being cubed.
Huh?
Mm-hmm. That's what I said. You don't have x squareds that are being cubed. You make it x to the 6th. That's point 1. Point 2. Each base appears exactly once. Anybody know what a base is?
Like an X or a Y.
Very good. It's one of your variables. Okay? It's an x, it's a y, it's a z. It's one of your variables. Alright? All fractions are in simplest form. That's always true. That's nothing new there. And the last one, the big one. No negative exponents. If you circle a problem for me and you have a negative exponent in it, you are wrong. It's that simple. Alright? So don't circle it. You have other things to do to it before you move on with your life. Alright, first one. So we're basically what we're going to do here for a little while. We're going to go through one simple problem that's kind of got each type involved with it.
Get the complex one.
And then we'll go, then we'll go harder, and that'll probably be it for the day. We're taking 2 days on this. Okay, this is a big deal. Or at least I want to make sure we have every single rule under control. Okay. Stone.
Does that mean we don't have homework tonight?
I don't know. We'll see. Depends. So this first one here, you have 2a squared times 3a cubed. So work your numbers the same way you always would. So 2 times 3 gives you what? 6. Great. Now you have a squared here and a cubed here, which gives you what? A to the 5th. The end. Now, yes, that's an easy one. You know what will eventually happen?
It'd be negative.
Eventually, well, obviously, yes, they're going to get harder, but here's what's going to happen. Once you start mixing all these rules together, everything in your head gets mumble-jumbled up, and you're going to start seeing this and making this 6a to the 6th.
Yeah.
Okay?
So,
Do not get your normal number operations crossed up with your exponent operations. 2 totally different sets of rules. Okay? Marts.
so if it would be 2a squared and then outside the parentheses is the c, or is the 3, that's when you multiply?
If it was a power. You'll see. You'll see one. Okay? Alright. Everybody good?
Yeah.
Okay, great. Next one. These are going to be quick hitters today, alright? 2q to the 7th over q squared. So you have 2, leave it alone. What happens to your q's? Subtract them, so 2q to the 5th. Okay, 7 minus 2. And that's it. X to the negative 12th. What do you do?
Just put it in parentheses times by x over 0. Times by x over 0. Put it in over x 12.
What in the numerator?
X in positive?
No.
Negative?
1. There you go. Okay, you got to put something. Whenever it's just that one term, and that's all you get, you have to have something in that numerator, right? You don't if you're moving it from the bottom to the top, right? Because your denominator 1's irrelevant. But if you move it from numerator to denominator, you better put this 1 here. All right, so x to the 12th, just like that. What do you think? Martz?
2x to the 12?
Almost. Alec?
6x to the 12.
Nope. Harris? 8x to the 12th.
Oh.
Okay, you know what you did?
Yeah, it's
Okay, you know what you forgot? Good. Okay, make sure this cube, first, and here's why I just said, don't crisscross your number rule with your exponent rule. Okay? That exponent of 3 goes to the 2, it goes to the 4. 2 cubed hasn't changed here. Okay? 2 cubed is still going to be 2 cubed, just like it's always been 2 cubed. Okay? So 2 times 2 times 2, giving you 8. X to the 4 times x to the 4 times x to the 4, x to the 12. Okay? So make sure on one like this, you don't forget to put that exponent to that number. Okay? That gets forgotten a lot. Alright? Everybody still good? Alright, let's keep going here. Keep on keeping on. I said that probably 5,000 to 6,000 to 8,000 times last week with the virtue being stamina. Yeah, keep on keeping on. Yeah, I think so. Yeah. We all need some of that, don't we now? Punctuality. What do we got? Stone.
X to the 6 and y to the 6.
X6, Y6. Take it to each one, just like the last one.
Yeah.
Everybody good?
Yeah, that's what I got.
All right. Everybody seems bored.
Yeah.
Yeah. Okay. Great. Let's move on then. Oh, one more easy one.
Nice.
Bless you.
Thank you.
Dory. Say the one word you're missing. You're missing a word. Over. X to 6 over y to the 6th. Fantastic. Okay, we all bored yet?
No.
I think this is a very nice chunky paste.
Ain't it though? I think so too. Just
Wait,
nice and
Just wait till the
just
next
nice and easy.
Next
And
slide's gonna
look
be
at
better.
look at this. I mean, this is
It's
so.
flowers.
Yeah,
It's
it's sunshine. Everybody's just here chilling like it's sunshine and rainbows.
Here comes the cloud.
Here comes the thunder.
And here comes the cold front with the thunderstorms. All right, now let's talk about this one. Write this down, then we'll talk about it. Okay?
I have an idea.
That's great. I want you to save that idea. Bottle it up like a bottle of root beer, and then we'll see it come spewing out. Okay? That's okay. I am here to teach you. That's my job. That's why they pay me the big bucks. Big bucks, you know. They're like $50 a day or so, something like that. You know, that's why I'm here. Yeah, the ramen noodle diet kind of bucks. Yes. Okay. At its core, let's look at this now. At its core, what type of problem is this? Starts with an M. Multiplication.
Dude.
You have two or three sets of parentheses. Okay? Everybody see that?
Yeah.
Now, here is what makes these types of problems hard. There's two things, in my opinion. Okay?
I got it.
One of them is what?
You have negative exponent and positive exponent.
No, that's not one of the reasons why this makes hard. Marks.
You have 3 different, letters.
No, I'm talking about in general. In general, what makes this hard? Nestor.
There's 3 different sets of parentheses.
Not just this example, guys. In general, how many rules do we have for this?
7.
7.
And there's more.
That's a lot.
There's 5 rules that we have to use in this one, probably.
No, I think there's 3. Yeah.
Dang.
Okay. There's 7, but there's 7 rules overall, right? That's a lot. Okay, that's a lot of rules to keep track of. Now, here's what else makes this tough. There's not one right way to do these. There's multiple right ways to do it.
Oh,
Are we going to start different?
No, gosh, no, we're not. Okay.
the fastest way.
I am going to teach. What I'm going to do is I'm going to do what I think is the best way. Okay, and that's the only way I'm ever going to show you.
Your opinion.
All right, that's the only way I'm ever going to show you is what I think is the fastest way to approach any one individual problem. Okay. So for this one, we have multiplication. Okay, so let's just do that real quick. All right, and then see where it gets us. Okay, see where it gets us. So we have 2 times 3 times what's in front of this c negative second? 1. So 2 times 3 gives us what? 6. Okay, great. Okay. Now, you have a to the negative second in the first term, and a cubed in the second term, and no a's in the third term. Combine them all. So a to the negative second times a to the third, which gives you a. Right? Because you add those exponents since you are multiplying those variables. Everybody see that?
Right.
So negative 2, right? Yeah. Plus 3, 1. Okay? Then go to your next letter.
B.
Go to B.
There's no other B.
There's only a B squared.
Yeah.
Okay, great.
Wait, this is being that. And then you
Can't that one have
Yeah.
negative? Sorry.
Now go to your C's. In this case, C is what?
minus 2.
Negative second. Okay, now for this one, I'm going to show that step. Negative second, right there. Okay. That's what I want you guys to do first when you see a problem like that. Okay. Do what its core is. If it's a core, if at its core it's a multiplication problem, do that first. If at its core it's a division problem, do that first. If at its core it's got an exponent that you got to deal with first, do that first. Okay? There are different ways you can go about this problem. I always try to get it down to the... I try to go to as few bases as possible as quickly as I can. I think that's your best way. Okay? You get it down to as few bases as quickly as possible. Now, there is still one thing wrong with this. What is it? There's a negative exponent. Now, here's the trickier part, okay? And I'm going to show you this work one time. Okay? Then you'll see the shortcut real quick, okay? Between the 6, the a, the b squared, and the c squared, c to the negative second, what's all going on? Multiplication. Okay? Those are 4 individual terms. Right? But they're all being multiplied together. Okay? So, when we go and make that c to the negative second be positive, watch what I'm doing here, okay? 6 is over 1, right? A is over 1, right? B is over 1, right? Now I'm making a point to put that dot times 1's in the numerator now, c squared is in your denominator. Right? Everybody see all that?
Yeah, so would it just be 6ab squared over c squared?
There you go. Now write it as one big fraction. 6 times a times b squared times 1 gives you
6ab squared over
1 times 1 times 1 times c squared gives you
c squared. You know, that wasn't too bad.
Now, do you have to show this step?
No.
Gosh, no. But that's why this is a correct answer. Okay, does that make sense?
Yeah.
Everybody in good shape.
And then if it's like
Yeah.
Once again, the easy ones, this is pretty simple for. Once you get to the complicated ones, and I think this is kind of complicated too if you don't fully understand the concepts just yet. All right, so bear with. You have 4 variables right up there right now, right, with 2 sets of bases. Everybody see that? You got Q's and R's. Okay? Just like how you had the multiplications, you're going to deal with them together. Same thing with your divisions, okay? You can do it as all one big division problem. You can split it off into 2. As long as it ends up back as 1 together, that's all that really matters. Okay? So this one here, you have q squared r to the 4th all over q to the 7th r to the 3rd. Do your r's first, just because they'll be easier.
It'll be R.
Okay? R, where at? Numerator. There you go. Okay? You have 4 r's up top, you have 3 down below. 4 minus 3 gives you 1. You have an r up top. Great. Okay? Now, this is going off to where I was talking about with multiple ways to do these problems. And this one I do have talked about kind of twice. Okay? Your first way to do this problem is to do it where you apply the division rule. Okay? You apply the division rule. And what I mean by that is you do the exact rule we just did. We did 4 minus 3 gave us 1. Do the exact same thing. Do 2 minus 7, which gives you what? Negative 5. So then you have q to the negative 5th. Everybody see that? Just like last time, you have to take care of the negative exponent. We do it the exact same way we did last time. Put it underneath r over q to the 5th.
Oh, I did it right.
Okay? Does everybody see that?
Yes.
Now, does anybody see a shortcut?
Yeah, when it's negative, just put it to the bottom.
No. That's what that is part of. That's part of the problem. It's not a shortcut. Out.
Subtract q to the 2nd from q to the 7th on the top.
Good. Okay. Think about this. Your exponents have to be positive, right? Okay. How many q's do you have in the numerator of your original?
The numerator top or bottom?
Top.
Well, you only have 2.
Then you have 2.
Bottom, you have 7.
Denominator, you have 7. Now, if they're going to end up being positive, they got to end up on the bottom. Everybody see that?
Roll up.
Yeah.
Okay.
Roll up.
Rule to follow, wherever the most positive exponent is, that's where your variable is going to end. See how 4 is bigger than 3 on your r's, so that's why r ended up top.
Right.
7 is bigger than 2, that's why your q's ended up on the bottom.
That's whatever one has the most.
Right.
It ends up on that.
Okay. So you can kind of fudge a rule here, all right? And this is where this gets a little messy. Even though this q squared is not negative, you can move him down. Just doing the q's now. And make him negative. Because when you move it, you change the sign. So you can go
You could just do 7 minus 2.
exactly, but you're doing it in the denominator now and not the numerator. Okay? So you can obviously see how this can get easy to get lost in. Okay? That's why it's always best just go back to your original rules. Those first like 5 or 6 problems that we did. Always keep problems like that in the back of your mind. Okay? Because that's going to help you be successful throughout this section here. Okay? Does that make sense? And then you would clean those up, right? Make it q to the 5th. Okay? Everybody good? Next. On a problem like this, okay, now today and tomorrow we're going to practice with, I'm going to have like a worksheet for you guys with all different kinds of these. You guys are going to work together, work on it, okay? But one like this where you have a fraction to a power, I always double check my inside, make sure it's as clean as possible. All right, get it down to as few bases as possible. This one's already that way. You got your number, you got A, you got B. So this one we're going to cube everything. Cube the top and cube the bottom, and cube each part of the top. That includes the number. Okay?
Right.
So, negative 2 times negative 2 times negative 2 gives you what? Negative 8. Good. A to the 4th to the 3rd gives you A to the 12th. Careful. Multiplying there. Over B squared to the 3rd gives you B to the 6th. Good. And that's it. Okay? You can have a negative number,
But not exponent.
but not a negative exponent. All right? You can have a negative number, just like always. All right? Don't get your old stuff crossing with this new stuff and like go, You can have a negative number, not a negative exponent. All right? Everybody okay? Everybody still with me? Great. The next two are going to be pretty easy. They just have to be in here because of future considerations. All right? So, here we go. Real easy rest of the day. Ready? Oh, I'm not. I'm literally not right now.
Ooh, that's tough.
What do?
You distribute
The plus, which means you're just going to.
flip the signs.
It's a plus.
Add like terms.
There you go. Like terms. 6x squared minus 4x squared gives you 2x squared. I just want to double check to make sure you guys can handle this. Negative 7x plus 9x gives you what? 2x.
That wasn't hard.
Plus 8 minus 5 gives you plus 3. And we circle.
Oh, yeah.
That's it.
I'm bad.
Okay. The end. There are no like terms when you finish this, right? Because you have x squared, x, and no x's. Okay. What makes things like terms?
Let's have the same.
Same base and same what? Exponent. Okay? Same base, and as we go forward, same bases, same exponents.
Ay, Dios mío.
Okay? So pay attention. They got it. The exponents have to be the exponents and the bases. Whole thing got to be the same. All right? Easy enough. Then you guys can get a couple more. That wasn't too rough.
One more.
Maybe two. We'll see. Oh, now what do we got to do?
Oh, is this the same as what we did?
This is not.
Yo, you distribute the negative.
There you go. Distribute your negative sign.
But then you don't know.
You do not because you have a minus in the middle. Okay, 4x squared minus 5x plus 6.
Oh, I was reading like last chapter. What we did.
No. Minus 3x plus 1. Get your like terms. 4x squared minus 2x squared gives you 2x squared minus 5x minus 3x minus 8x plus 6 plus 1 plus 7. Circle it. Okay. Also not terrible.
Plus 7.
Mm-hmm. All right.
That's not that bad.
Not bad.
Not bad at all.
Okay. Maybe this one might be the last one. We'll see.
Ah,
Can you write in the note?
What do we do next? What do we do with this one? Nah, distribute. Okay. Ooh. Okay. So 3x times 2x squared. So you see how this is kind of taking your exponent rules and putting them with this problem and everything? Okay, everybody see that? So you got 3x times 2x squared to give you what? 6x cubed. Good. Minus, you got 3x times 4x to give you 12x squared. 3x times 6, 18x.
did you add the exponents?
Mm-hmm. X times x squared is x cubed. X times x squared. X times no x is just x. Okay? Yeah, one more. I think we can handle it. I think so. I think we got it. One more.
Because you're packing up.
Why do we want to end on? Why end on that one?
Because that was a good one.
That's not a good one.
I felt that one.
That's not a good one. Ed. Don't you want to leave? Don't you want to leave feeling accomplished?
No.
I feel pretty accomplished.
Don't you want to leave feeling accomplished and not like unsatisfied?
I need to go
Like, is there not an urge deep down within you that, bless you, makes you want to feel like you need a challenge and you want to finish on a hard problem and be successful? Walking out, ready to kick down blazing doors, like, yeah, I just did that problem.
No.
Good, too bad, because here you go.
You made that.
Stop it.
This is an L. That's an L.
Why is this an L?
Because it's a fraction.
So what? Dimitri, explain this problem.
Okay, so first you distribute the exponent, and so you distribute throughout the entire problem to get a number x to the fourth plus a number x to the third minus an x to the negative second, and then you multiply everything by 4/3, and then you get 8x fourth plus 12x cubed minus 16x squared.
Why? Why do you get those numbers?
Because you got to divide it by 3 after you
Times them by.
times by 4.
Look at your numbers. 6, 9, and 12. They're all divisible by what? 3. So you can distribute that 1/3 part through first. Okay? Cut these all down by 3. Okay. Then you have, yes, 2, 3, 4, which gets care of that 3. Now do 4 times 2, which gives you 8. That's fine.
Oh, I feel confident.
4 times 3 gives you 12. That minus sign's a little off where it should be. Minus 4 times 4.
I just did 4/3 times 6/1.
That works too. Okay. So Dimitri, to recap, was this problem an L or a W?
It was a dumb. It was a
It
big
was
boy
a
dumb.
W. There you go. Okay.